All right, so I know some of y'all are still typing stuff in, and that is totally fine. Just putting your this data, your data for this your first part, into Desmos. So here's my data. Yours should be similar. It's okay that it's not exact. We don't expect that. Remember, we have a large room for error because we are measuring with M&Ms, okay? There's a margin of error no matter what, but when you're measuring with M&Ms, there's a whole lot more. If you were watching the video because you weren't here, then just use my data, but here's the rest of it. So if you just kind of scan your data and my data, in theory, for parts 1 and 2, our data should be exact because we were all measuring the exact same thing. But again, since we're measuring with M&Ms, clearly not. Part 3, in theory, again, we should all get the same thing, but when it was experimental probability, we do expect for these to definitely be different, okay? All right, so when I look at my graph, so here's graph number 1, and hopefully you have gotten this data put back into Desmos if you've already done it. And before you even did that, did you think this was linear, quadratic, or exponential? Linear, okay. So I would agree that it is linear. And then I'm going to write down the equation I got. And again, ours should be similar to each other. Y equals 5x. Okay. So this is what I got. Your slope hopefully should be semi in the same ballpark-ish, right? And then your y-intercept should be pretty small. Are you shaking your head like, nah, we're not even close? So what's happening? What do you have? Let me see what you have. Oh, no. But yeah. Your y-intercept should be pretty small. It might be negative, but it should be pretty small. But this number should be pretty close, in the same 3-ish ballpark. Okay, yeah. But yeah, if your y-intercept is minus, that's totally fine. Okay, that makes sense with the data. So let's talk about, besides the fact that it clearly looks like a line, and when we go to Desmos and click on things, it looks like a line. When we look at our data, if it's linear, then we should have, our first differences should be the same, right? And so this is 4, this is 5, this is 5. They're kind of close. Ooh, that one's 11, that one's 9. So they're really not all the same. But that only occurs when you have equal length input value intervals. Do we have that? No. That's why every time we do something with data, we look at the x's first, and we see those differences. They have to be equal length input value intervals for us to make those observations. So remember that. That's why it doesn't look like that from here. All right, so another reason we would know that it is linear, even if we didn't have all the points, we're talking about circumference here, okay? So there's 2 ways to do circumference. Circumference is 2 pi r, and circumference is pi times diameter. It's definitely something you should know, okay? So circumference is pi times diameter. If I wrote that, and look what we have. We have circumference into diameter. This is circumference as a function of the diameter. If I put this in y and x form, this would be y equals pi times x. Where, what is your slope in this case? What's the slope of this line? Pi, right? Look at this. Is yours kind of close to pi? If it was kind of close to mine, it kind of is, right? It's like in the 3-ish ballpark there. And then your y-intercept is really small because really, technically, we shouldn't have one, right? It should be 0. If you think about what we really did, we had circles and circumference and diameter. So if my diameter is 0, what's my circumference? Hard question of the day. If the diameter is 0, what's the circumference of the circle? 0, exactly. So when we go here and look at our Desmos, okay, that you already have that typed in, then I want you, you know what you have, you've already written that down, but I want you to put in another point, and I want you to put in 0, 0. And when I do that, my slope changes to 3.14. Well, that is pretty darn close to pi. Did that make yours closer to pi or farther away, do you think? Closer, okay? Because that was, I mean, obviously that should be the same for absolutely everybody, no matter what. And then that just, you know, I still, in my regression, I still have a y-intercept because it doesn't always, you know, obviously it's a regression, it doesn't necessarily use these, but it should be even closer to 0, I think. Okay, so one thing I meant to do right here is that pi, which we know is about 3.14159, blah, 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 and this looks like pi-ish. It's pi-ish. Okay. Now, I said the words, it is the circumference as a function of the diameter. Now, nobody said on here that we had to write this in function notation or anything like that. But if we did, if I actually had like a table that had it labeled that way or whatever, then how I would write it would be the circumference is a function of the diameter, and then that is equal to, I'm just going to use the same point, one I have, 3.1315, so you can use whatever yours was. But I don't put x, I put d plus 0.2831. So I'm sure you have noticed that your multiple choice part from your test from last week is in the computer. Your the calculator part is not, because I'm not through grading it. When I got through one class period, I had written, I decided I got to go get, I went and I got an M stamp, and I'm going to stamp y'all with the scarlet M every time you call something other than what it really is. You're all being a bunch of Melissas. I didn't actually count, but I think overall for all day long, there was only 5 people that didn't get a stamp. Now, there were quite a few people that, and I think it was C of T, that started off with C of T, but then put X here. That still makes it wrong. Then yours really doesn't make any sense. At least if you used Y and X, it makes sense. If you put C of T and X here, you don't, you know, you understand how that doesn't make sense? You are not going to get credit for those things, okay? So you have to be very diligent about that. On here, it's fine that we had Y and X because that's really all it was saying. But when it's asking you to write a function and you have a table of values that has T and C of T, those are the variables you have to use or what you're saying doesn't make sense. Are you with me on that? And we are going to get those back. We're going to go over those as a class because there's a lot of things on there that I want to talk about. Because there are so many of you that really, really close to getting full credit, but just a little not, right? And so we just need to kind of get that stuff fixed before we move forward. All right, any questions about your linear? All right, so then I want you to type in your, now here's something you can do if you want to, just as future reference. Sometimes it gets a little bit much and people don't like it, but when you are here, if you got to do something else, you can either X out what you have, or you can turn this stuff off and leave it there in case you need to go back to it, and then type more in there. I mean, that's a personal preference. Me, I think I'd just exit out and start over. But go ahead and type in your area data. Type in your area data. Now on this one, as I was going around, and I know not everybody got to this point in the lesson yesterday because some people didn't get everything graphed or whatever. From the people that I did walk around and had this and had chosen something, there was some disagreement, okay? So somebody tell me what they think their data is. Quadratic. And I know I had a lot of quadratic circled, and I had a lot of exponentials circled. I think the only thing everybody agreed on 100% was that it wasn't linear. Would you agree with that? Okay. So you got your quadratic stuff in there? Yes? That's not your quadratic. That's not the right stuff, yeah. All right, so got our second one in here. I'm going to tell you, it is quadratic, and here's how we know, and don't erase anything. I got a little ahead of myself there. So if I do it this way, well, quadratic, looks decent. Exponential, looks decent, right? If you're just playing around on here, it's kind of hard to say which one's better necessarily. Would you agree with that? Like you're like, I'm not really sure which one I like better, but we'll see. So how would we know from our data? When we look at data, there's a couple of things that we can do. Now, it's a little easier to test exponential by just looking at it than quadratic sometimes. And so when I went around and talked to people, their y values, I mean, I could see why maybe they would think it'd be exponential. Mine, not so much exactly, but we would need like a common ratio, right? So maybe 1.5 times 2, it's not really 7, but 7 times 2 is kind of close to 16. 16 times 2, like maybe for your data it was kind of working. So I could see why maybe you would think that. However, that sort of thinking is completely irrelevant here because we do not have equal length input value intervals. You with me on that? So great that we're looking at that because we should, but that only works if we have equal length input value intervals. You with me on that? And so even my second differences here wouldn't help me because I don't have equal length input value intervals. I would have to actually find the rate of change and then see how my rate of change is changing. But that's a whole lot of stuff, and we're not going to do that. Let's talk about how else we know. Because one of the things we talked about when we started regression was, how do you know if I just give you an explanation of what's happening, I don't give you data, there's nothing for you to actually look at. So if I said, oh, we're going to do this, and we're going to graph the diameter of the circles versus the area of the circles, whether we're using M&Ms or string or rulers or whatever, like what type of function do we think we're going to get? Well, one of the things we talked about is that if it's quadratic, and then, if it's area, then area goes with quadratic because the units are squared and it's area. That's how you can kind of connect that all together. Here's how we know specifically, actually, let me write down, does everybody now have their regression? Let me write down what mine is, and then we'll talk about that a little bit more. So I got y equals 1.007. I don't know why I'm writing so many decimal places. X squared okay. So yours should be sort of in the same ballparkish as mine. And some of the, like when I have minus, if you have plus, like that could happen just because of the way things are working. But that one's a little weirder. But here's why we know that it is quadratic, because area is pi r squared. Our graph over here is area as a function of the diameter, right? Diameter is the input, area is the output. Therefore, area is a function of the diameter. Well, right here, I have this as area as a function of the radius. Well, I know that the diameter is 2 times the radius. So that means the radius is diameter over 2. Do we agree with that? So then if I substitute diameter in for radius, this would give me pi times d over 2 squared, which gives me pi times d squared over 4. And then I can rewrite that as pi fourths times d squared. Everybody okay with that? So that is area as a function of the diameter. And pi fourths, just so you know, pi fourths is about 0.7853. Okay, it's about 0.7853. Now, how does that work with this? Well, again, we shouldn't have any vertical shifts here. Your y-intercept should be at 0, 0, because if I have a 0 diameter, I have a 0 area. Would we agree with that? And so really, if I could force this to be what's called a power function. Now, these aren't functions we have to know the regression of or whatever. I'm just going to tell you what they are, and then we're going to just kind of look at the data. But a power function would be like y equals x cubed, or y equals x to the 5th, or whatever. And maybe we have a stretch in front of it, but we're not going to shift it left and right and do any of that stuff. That's a power function. I would basically just have one term. It's called a monomial. So if I was to force mine into that, which I couldn't figure out how to make that work exactly on Desmos, we're going to sort of estimate ours in just a little bit and talk about why we know we're kind of close. Then what I got was y equals 0.7939 x squared. Well, if this is pi fourths, this is pretty close to pi fourths. Would you agree? So basically, my experiment there with the M&Ms basically got me pi fourths times the diameter squared. Okay, so let's see how close yours was to this. But here's what we have to do, and we're going to talk about some little extra stuff in here as well. So if I go back to Desmos here, and I have make sure it's on quadratic here. First of all, this, oh no, never mind. This is the thing I actually wrote down. When you click on the regression, there is something called power regression. So I want you to click on that with your data. So click on power regression, which requires you to put your fingers on your computer. Okay. Then, well, this is not what I wrote down, is it? Okay. So here's a whole other side lesson that should have been part of 2.5 when we did it, and it wasn't, and it's 100% my fault, and I apologize. Because every example we did in the notes, which I totally did rework and rethink through before I actually did the lesson, everything worked out nicely. I did not, however, ahead of time, rework the assignment, and something sort of slipped my mind because I haven't used Desmos to teach this stuff before. If you were in Pre-AP Algebra 2 last year, then you probably recall your teachers losing their freaking minds when they were doing exponentials and logs because they couldn't get the same answers as the answer key, and y'all weren't getting this. It was like a mess at first until we all figured out why. This little thing right here that pops up, log mode, you see that? You may or may not have it, because last period I had a group that didn't. It depends on your data. Right now, you might not have it. It might not pop up every time, okay? It has to do with, okay, so let me just back up. The reason that none of us really even thought about this is because every handheld calculator any of us have ever used in our lives, the default is log mode, so you don't have to choose it, all right? But it has to do with how the regression is done and how you can linearize things, and it has all these statistical things behind it that we don't have time to talk about, and that I had to reread the little question mark thing about 10 times to understand what it was saying. But it has to do with the error, which we haven't talked a whole lot about, but on yours, do you see this little r squared right here? So the default for Desmos is whatever would make this r squared number closer to 1. So it might default into log mode. This didn't, so I'd have to choose it. Here's what it boils down to. If that ever pops up in regression, you click it. I don't care what kind of function you're doing, because everything is done like what you handheld. So that's why this number, I don't even know if you can see it. It's not what I wrote down. But if you click log mode, and then if you, again, you might not have it, but I want you to just look at that r squared number. So when I clicked it, I have 0.9917. When I unclick it, I have 0.9924. Since that's closer to 1, that's why that's a better function. But again, if we click it, now when you look at it, look at your exponent. Is your exponent kind of close to 2? In the ballpark of 2, right? Because we're trying to get an x squared function. And then your number in front of it, is it like a 0.7 number? It's going to be a little bit more farther off than pi fourths because the exponent is off. Again, I couldn't figure out how to make it an x squared power function on here, but that just kind of gets you an idea of what's happening there. Plus, it lets us talk about log mode. So another side note about log mode. What this means is this, and I apologize to those of you that have actually done your stuff and do your stuff ahead of time. On the 2.5 assignment, if you had to put the reason it didn't matter on the notes was because we only had 2 points, and if you have 2 points, it's going to work out nicely. When you have a lot more than 2 points, then it might not, and you might have to click that log mode, and nobody told you that ahead of time. So if you went through and did everything and just got it from Desmos, your answers are likely wrong. Okay, and I apologize for that. And again, we'll talk about that again when we come back from Thanksgiving. But I'm just putting it out there that you might, now if they gave you the equation or whatever, if it doesn't pop up, and I will go back through that assignment. I'm going to rework it hopefully today, and I'll send a reminder that said these are the ones where log mode popped up, so you don't have to feel like you have to go back and redo everything. Okay, but maybe the fact that you're going to have to go back and redo it will help you remember in the future to always do it, even though you didn't know to begin with. All right. So all that to say that really, yes, this is quadratic. We were trying to get a quadratic power function. Any questions about that one there? All right. So now I want you to type in your survivor data. Type in your survivor data. Oh, and I needed to do. Oh, I got it. And then I'm going to write up there what I got, and then did we all agree on this one? Now this one looks like could be quadratic or exponential as well, but I think we all agreed on what this one was going to be, right? Quadratic wouldn't make sense because there's no way for it to go back up. So I think we all agreed on exponential there for sure. Now, what we did was basically experimental probability. The theoretical probability of that is that if I drop 100 M&Ms, 50 of them should land heads up, right? Because it's a 50-50 shot. So really, we should be dividing the amount in half every single time. When you look at your data, it's probably pretty close to that, right? I mean, it's about that, but like when I got here, then I didn't divide at all. I mean, that happens, but I mean, these were actually fairly close, which, I mean, has nothing to do with who's doing it. It kind of surprised me that mine was that close to being half most of the time. Because again, it's just reality and what's happening. So that means that if we have our y equals a times b to the x, right? We have that, then the b should be 1/2 in theoretical probability, right? If this was just in theory, this is what would happen. So that means in your equation that you have this is your A part, this is your B part. Is your B in the 0.5 range? I would think it'd be pretty close to that. And what does A represent in these functions? The initial amount. So that should be at about 100, right? Which mine's kind of far from 100, but I mean, and I'm going to show you something else here in just a second. But I mean, it's 100-ish. Again, it's probability. Probably the 3 at the end is probably what really threw mine off. But okay, so if we look at our data, I think hopefully we all have our data in there now. Okay, so if we look at this, and we knew it was exponential, that was all fine and great. But again, you may or may not have this little log mode here. Okay, so just look at mine real quick. See these numbers. I'll write it down in a second. But so right now I don't have log mode clicked. My R squared is 0.9985. You don't have to know what R is. We'll talk about residuals and stuff, but this is different. I'm just throwing that out there. If you do statistics, we'll talk about it a little bit. But again, this is why it's choosing log mode or not. So it's saying log mode is not the best. When I click log mode, then I get 0.9756. That's like way farther off from 1. So you can click back and forth if you have that and look how your equation changes. But your correct equation is the one that has log mode checked. If you don't have that option, that means the log mode for your data was the best one, okay? So again, just so you know, I can't say that it will show up every time on certain things. It may or it may not. So you just gotta, if it's there, you gotta look for it. All right, so here is, I'm gonna write down what I had as this was my non-log mode, which is basically the wrong answer, but my non-log mode. And I got 100.756 1 times 0.5131 power. Well, do you see why they say that's a better way to do it? Like, isn't this way closer to what we would expect to get? I mean, this is almost exactly 100. This is almost exactly 0.5. So if you just look, you don't have to write both of yours down necessarily. It's up to you. But I do want you to look at both of them and see how the other one, it might be a closer to 100 and 0.5. But again, this is the correct one. We always choose log mode. Okay? What questions do you have? All right. If there are more than 3 people at your table, then the first one to say not it gets out of doing something. Yeah, yeah. Okay. Now, one more at this table. I think Grace got that one. All right. So you should have 3 remaining people. You just get out of it because you're back there. 3 remaining people. So of the 3 remaining people, one of you is circumference, one of you is area, one of you is survivors. Figure it out amongst yourselves. Make it quick. Okay. Then, unless you were the not it person, I want you to go to Canvas. All right. So the not it person doesn't have to, but if you are not the not it person, that means you are the it person. You go to Canvas, go to assignments. The first thing up at the top on assignments for upcoming should say something like M&M data. Okay. And I'm going to do this differently than I did last period because it didn't work out so well because I had to do it differently than last year. So the only people that are going to be typing anything right in just a second are going to be the circumference people. And then we'll move to the area people, and then we'll move to other people. So circumference goes first. All right, so here is a Google Sheet that I made of, basically this is just my data, but you can see over here. Okay, once you get in there, circumference people click circumference. Other people don't click anything yet. And you will get something that looks like this. My data is in there. I'm going to give you a group number in just a second. All you have to do is type your data in here, but no typing yet. Because here's what we're going to watch. So here's mine, and that's my equation, right? We're going to see with more data, does that slope get closer to pi? Does it get farther away from pi? Does our x-intercept get closer to 0? Like what's happening there, okay? So here are your group numbers. 1, 2, 3, 4, 5, okay? So circumference people, go forth and type, and we can kind of watch this change as they do it. Everybody understand the assignment? The fact that y'all are typing and nothing is changing is about to make me freak out. That probably means that my links are wrong, and then I'm going to scream. Oh, no, there we go. I was like, what is happening? Your circumference data, your first set of data up there. From the other side in the table that you wrote down. Come on, you got about 10 seconds left. This isn't hard. Type, type, type. Whose circumference here? Why are we confused? Oh, okay. Thought it was you and you still looked confused. I was making sure. What happened? Oh, no, that means somebody typed something weird in. Yeah, group 3, yeah, there you go. It's okay, it happens. And as they type, like it changes greatly because they don't have other stuff back up there yet, but. Okay, so here's another little thing to talk about statistics and some outliers, okay? Outliers, the ones that like, one of these things is not like the other. Like really for this circumference, somebody got that big of a number. I think maybe somebody else typed in a wrong number again. Go back and check your numbers. Maybe I should have had more than one person click on it to make sure we're right. There we go. Okay. People are still typing. So there's still, I think, a couple of, it's going to happen. Whatever point this is, it's probably not typed in wrong, but would you consider that probably an outlier right there? Like, and if we took that out, maybe it would fix things, who knows? But again, we're still really close to pi, okay? I don't know that it helped us any, but I think it has something to do with that point. Let's see. That's at 12. What are our options here? 41. Well, group 4, why don't we have anything in there? Oh, were you fixing it? Was that what it was? There we go. And I don't want you to lie or anything. 39, 41. Okay, whoever had that 41, I'm not saying you were wrong. I'm just group 2. Will you just take out your y value? Oh, no, it's not a 41. There has to be another like 45 or something. Your 41 was fine. What am I not seeing? Oh, 44. Okay, group 2, group 3. Again, just take that out and take out the 12 too, so that it just doesn't. All right. So if I take out the outlier, okay, which again we're measuring with M&Ms, y'all are fine. It's no judgment at all. But that gets us a little closer to pi, right? And there's probably some other ones that weren't, and that wasn't a huge outlier even. I don't know that that would even fall in the category because it wasn't that far off. But I just want you to see how it affects your data there. Okay, we good on that? All right. So now the area person, I want you to click on area and do the same thing. Here's our graph. And in Google Sheets, look at how they wrote my equation. Like instead of putting x squared to x and then the constant, it's completely backwards. Like I didn't choose to do that. That's just how they did it. I couldn't figure out how to control a lot of things. I figured out how to do it. I couldn't figure out how to like make it what I wanted. But once everybody's done, because remember when we looked at quadratic and looked at that form, I don't know if that really helped us because it didn't really go with that whole pi fourths thing. But once everybody gets their stuff in, I'll show you the power regression on this one. Okay, are we done typing? Can't tell if it's changing anymore. Okay, so remember on this one, I tried to force that power regression. There we go. If I do that here, make it a power series, you can see that this is close to 2 close to 2. This is way farther off from the 0.7, but this is also pretty far off from 2. That's what accounts for that difference. But again, it probably has something to do with some outliers that are technically not really outliers. But if we, we won't do this time, but if we took out some of these points that are a little bit farther away, then that would adjust itself a little bit more. So just want to show you. I'm also interested in seeing how many classes like the data really falls exactly where it's supposed to be, or should be, basically. All right, so then survivors. You click on yours. First of all, when you look at this equation up here, what do you notice about it different than what any of us wrote down? There's an E in it, okay? And we'll talk about that when we're done here, but go ahead and get your stuff typed in. Make sure you type in the 100 and the 0, because I don't know that I did. Or 0 and 100, rather. Yeah. Because you didn't actually write it, but you need to type it. And the default for Google Sheets, log mode. That's why none of us really knew that that was even a thing until we started using Desmos. And I always think like, and I have a math degree and I've done more of this stuff than you could even imagine and just never even was a thought. Okay, so are y'all thinking maybe some people are typing some stuff in wrong? Just maybe. I won't call out what group it is, but fix yourself. Yeah, there we go. I think we still might have some wrong numbers in there, but it happens. Right, and that's why I say when you type stuff in, double check yourself. First of all, so you don't get called out in the middle of class, or your group doesn't get called, but also so you don't mess yourself up. Like, this is a hot mess. What is happening, people? Yeah, maybe somebody like, I think we're getting X and Y mixed up here. That could be a huge problem. Getting there. Okay, are we done typing? All right, now, let's look at this, although I think somebody has 1 and 100, so, which is possible. Is it possible that you dropped them all and they all were heads up? Definitely possible. Possible, but not probable, right? Okay, all right. Now we think we're good? Okay. Are we still, is anybody still typing? If you are, that's okay. I just want to know before I do it. Okay. Oops, somebody is. Y'all are lying to me. Who's still typing? It's fine. I just need to know when you're done. That's all. Okay. So I need to write this down because I'm going to click off of it. But so we have 100 times e to the negative 0.647 power times x. All right. So our initial value is 100. We're like spot on with that one. Would you agree? But that e, we can't really compare. So I want you to think about this. That we talked about equivalent forms, right? So if what they just gave me is y equals 100 times e to the negative 0.647 to the x power, okay? That's what it says all of our data together gives us. Well, this should be 100 or close to it. We agree with that. This should be, the b should be 0.5. But if I rewrite this, 100 times e to the negative 0.647 power to the x power, now I have it in the a times b to the x power. So somebody that still has Desmos up, maybe a couple people, because I don't know, we can trust some of us typing, myself included. What is e to the negative 0.647 power? Somebody, anybody? What do we expect it to be close to? 0.5. Okay. None of y'all are willing to type for me? Thank you, Mario. What did you get? 0.5236. Okay. Equals 0.5236. So really, I could rewrite this as 100 times 0.5236 to the x power. Okay. So this is why change, the equivalent forms can matter, whether we have it in the in E form or not, and whatnot. Okay. What questions you got? Anything? All right. So hopefully you got something out of this. A little bit of regression information, how the numbers all work together, how to do this stuff on Desmos. We good? All right. So go ahead and put that in your ISN. You can shut everything down.